Hi everybody, today we are going to be looking at the unit 11.1.2 simplified by using the product, quotient, and power rules. So if you guys want to grab out your notes, we're going to go through these examples and then we'll stop the video and I'll restart recording for the next topic. Okay, so today also you're going to see a lot of the things in there where it says discover the rule, expand the following. So some of you might remember some of your exponent rules, but this is giving you the explanation for why. Like, why does that rule actually work out? And so here we're just going to be expanding the following. So this first one right here is just going to be 3 because we know we've got 3 to the first. And then we know that 3 to the 0 is just going to be 1. And then here we're going to have 3 times 3, and then times 3 to the first is just going to give us 3. So then, you know, you're asked, it's like, well, how many 3s did we actually come up with? We have 4 of them. So we actually had 3 to the 4th by the end of it. And it just asked us to expand the following. So really all you're going to need is this. But then I would like to pose the question to you, well, how many 3s did we end up with? So let's look at what happens on the next one. So this next one, if we've got, it says x to the third, we're going to take x times x times x. And then for our next piece, we're going to have x times x times x times x times x for 5 of them. And then for that last one at the end, my pen tool has gone away. All right, so the next one, this piece right here, it's going to be 1 over x, because remember, if you have x to the negative 1, remember from the last lesson, in order to make that positive, you just move that x down to the denominator. That gives it a positive exponent of x to the first. And x to the first, we don't have to write x to the first like this, because x to the first is just x. So that's why we didn't write that on there. So then if you're looking at like these two right here, x over 1 times 1 over x, those are reciprocals of one another. And then those reciprocals, if you multiply them together, they just equal 1. Because again, kind of taking this piece up here for a moment, x times 1, that's the numerator, all over 1 times x, that's the denominator. That's going to give you x over x, and x over x is just going to reduce to 1. So this gives you 1 for here. So what that means is that those actually cross off and they reduce to 1. So then how many x's did we end up having? So we had 3 from here, 4 here. So we have ending up having x to the 7th for that last one. And so what I would like for you to do is look back at your exponents of the problems that we started with and say, well, how does that compare to what we got for our answer? So here, if we took 1 plus 0 plus 2 plus 1, we would end up getting 4. So we would have 3 to the 4th. And same thing over here, if I said take 3 plus 5 minus 1, how many do we get? We get 7. So we get x to the 7th. And that's why in this next part, the product rule for exponents, that's where that rule comes from, and that's how it works out. So the rule states that if you have get rid of this. The product rule states for exponents for any non-zero number, so here any non-zero number x and any integers. So remember integers, if you don't remember what those are, you might want to write yourself a little note off the top or bottom of what the word integers is. Integers are any positive or negative whole numbers. So if you have any non-zero number x and any integers a and b, so those are your exponents, then we can use the rule that we're going to have x to the a plus b. And that's going to be our rule. So we can, as long as our bases are exactly the same, so like up here we were dealing with 3's all the way across, here we were dealing with x's all the way across. If we have that case, then you can just add their exponents. And so we're going to apply that rule in the next 2 problems. So here it says simplify the following. So I'm going to follow order of operations. We're going to take care of that part first. And it says n to the 3 times n squared. And when I say take care of it, I'm just going to write it out so we don't have parentheses, because the only thing that parentheses is doing at the moment is saying that there's multiplication, and that's the entire process all the way across that problem. So I'm just going to take away the parentheses because they're unnecessary in this problem, and I'm going to have n to the -4th. So if I'm following my rule over here, then we are just going to say they're all the same base of n, and so it's going to be n to the 3 plus 2 plus 5 minus 4, or you could write plus a negative. That works as well. So 3 and 2 is 5, 5 and 5 is 10, 10 minus 4 is going to give us 6. So we're going to have n to the 6th in here. Then for our next one over here, same thing. I'm going to go ahead and get rid of the parentheses because all I have is multiplication going on between this term and this term. So I'm going to go ahead and drop the parentheses, and I'm going to write 5 p to the 3rd q times -3 p to the 7th q to the -1st. And then what I'm going to do is I'm going to use the commutative property of multiplication. And commutative, think about what the word commute means. Just means we're, like if you're commuting to and from work, to commuting to and from school, that means you go to school, back home. From home to school, school, back home. You're just trading places. And so that's what the commutative property says too, that the terms can trade places over multiplication. And if you look, that's exactly what we have. We only have multiplication going all the way across this term. And so what I'm going to do is I'm going to bump my numbers to the front. I'm going to put my p's together, and I'm going to put my q's together. And then I'm going to add their exponents. I'm going to take care of that piece. So then here we're going to have 5 times the -3, which is going to give me -15. Here I'm going to combine these exponents of 3 and 7, so I'm going to get p to the 10th. And then here I've got q to the 1st minus 1, which is going to be q to the 0. And then you should remember, what is q to the 0? That was from last lesson. So that's just going to be 1. This goes to a 1. And so what that means is that we've got -15 p to the 10th for that answer. So that's just kind of applying that rule. So now we're going to expand the next couple of examples because we're going to discover our power rule for exponents. So discover this rule, and it says, expand the following. So this right here tells me I'm going to have 5 sets of 3 squared. So here's 1 set, 2 sets, 3 sets, 4 sets, 5 sets. So we've got 5 sets of 3 squared, and now count them up. How many 3s do we have? So 2, 4, 6, 8, 10. So that would be 3 to the 10th here. Well, how does that compare to the numbers that we started with up there? I'm hoping that you're saying, Liz, we're just multiplying them, 2 times 5. And that's correct. That's what we're going to end up doing with those exponents. So if we were to check this, we would know that it should come out to n to the -8. Well, let's find out. So this would mean n to the -2nd times n to the -2nd times n to the -2nd times n to the -2nd. So we've got 4 sets of those, and again, add them up. -2 minus 2 minus 2 minus 2 is going to give us n to the -8. The other way that we can rewrite this, again, this is from the last lesson. If we were to rewrite this with positive exponents, we would do 1 over n to the 8th. And you need to be able to convert both ways. So be able to write it so you've got it in negative exponents, and then also express it with positive exponents. So what's the rule? The rule for our power rule for exponents is that for any non-zero number x and integers a and b, we're going to multiply those exponents. It's going to be x to the a times b. So that's a multiplication sign right there. X to the a times b, or sometimes you'll just see it written like this. And then it's implied that there's a multiplication sign in between those 2 letters. So let's look at some examples. So in these examples, I'm going to look at the fact that, looking at this one, that entire quantity in parentheses is taken to the 0 power. So that's going to be 1, right? So this entire piece right here is going to go to 1. So right now we've got -1 times, and then here we're going to take times 2 to the 4 times 3, which means we've got -2 to the 12th. And then you can go ahead and then just multiply that out and say, well, what is 2 to the 12th? And so 2 to the 12th, put that in your calculator, 2 to the 12th power. You should be getting -4,096. -4,096. And I would double check that. Make sure you can do that in your own calculator. For our next one, I'm going to take care of this piece first, and then we'll talk about the x to the third. So I'm just going to bring down the x to the third. Here we're going to multiply these two exponents. So it's going to be x to the -20. And then what do I do with the exponents now? And the answer is you should be adding them, right? So this first rule I used was the power rule for exponents. And then this rule here is going to be your product rule for exponents. So you should be adding them. So 3 minus 20 or 3 plus a -20 is going to give you x to the -17th or 1 over x to the 17th for that one. So number 3, let's check her out. So here I'm going to take care of this one. So we've got -b times b to the 24th. Because again, we're multiplying those two together. And then you should ask yourself, what's the answer going to be to the next one? Is it going to be b to the 23rd? Is it going to be -b to the 23rd? -b to the 25th? What do you think it's going to be? So I want you to think about that. You should pause the video and see if you can figure that part out and then see what you get. So remember, what is the exponent on this b? It's 1. So pretend like that negative is not even there. Pretend like it doesn't even exist. And you're going to combine these exponents. And so we're just going to bring the negative down. It's our placeholder, right? And then we still have our base of b, and it's going to be -b to the 25th. So this is one that oftentimes students will say, wait, I thought that was going to be b to the 23rd or -b to the 23rd. It would be b to the 23rd if the negative was on the exponent of 1, right? So if it was b to the -1st times b to the 24th, then it would be b to the 23rd, but that's not the case. All right, so let's look at the next part. So the next part is a quotient rule for exponents, and that's the one we're going to be discovering at this point. So in the numerator, it says expand the following and then simplify. It says m times m times m times m times m. I have no idea why my pen just changed colors for a moment. All over m times m. And again, I put them like that because m over m is going to reduce to 1. So that means this piece right here is going to be 1 over 1, right? Because m over m is going to equal 1. M over m is going to be 1 again here. So what am I left with? I'm left with 3 m's in the numerator. So it would be something like this. Do I need to write it as m to the 3rd over 1? No. You just write m to the 3rd. Like that. And then you would compare. Okay, well, how does my answer compare to what I started with? What you started with up here, I'm hoping you're seeing the pattern of, okay, how does 3 relate to 5 and 2? You would take 5 minus 2, and that's going to give you 3. So in our next one, we've got x times x times x all over x times x times x times x. We're expanding the following. How many x's do we have? 3. How many x's do we have here? We have 4. So okay, let's start crossing some out. X over x is going to be 1. X over x is going to be 1. X over x is going to be 1. So a lot of times students will tell me that means we have 0. We have 0 in the numerator. Nope, not true. We don't have a 0. Look at what we have up there. We have 1 times 1 times 1. Well, 1 times 1 times 1 gives us 1. 1 times 1 times 1 times x is going to give us x. So our answer would be 1 over x, or we write it as x to the -1st. And you need to be able to write it both ways. X to the -1st. Well, how does that 1 over x, or x to the negative first, relate to what we started with? Well, if you did like this, x to the third, and we did 3 minus 4, so up here, we did 3 minus 4, you're going to get negative 1, right? So x to the negative first. If instead we brought these 3 down, and I said, okay, well, let's actually bring these down here, and then we would have 1 over x to the fourth times x to the negative third, right? Because if we bring it down, that exponent becomes negative, right? So then 4 minus 3 is still going to give you x to the first in the denominator. So that's how that relates. That's how our answer relates to what we started with. All right, so what's the rule? The rule is going to be if we have x to the a over x to the b, and again, you're checking to make sure that it's the same base of x, which it is, you can either have x to the a minus b for that, and typically what that would be for is if a is greater than b. That's not always, but typically that's when we will use it in this class, is when a is greater than b. So I'm just going to write that in. And again, this isn't always, it's not like you always have to do it when a is greater than b. It's just typically. So typically when a is greater than b, or we might have 1 over x to the b minus a. And this one is typically when b is greater than a. Not always, but typically. Because for example, if we rewrote it like this up here, this is us still using x to the a minus b. We just ended up getting a negative number, right? So that's fine. This answer right here, I don't know if you can actually see my mouse when I'm pointing, so maybe I should tell you that. So this answer right here is when we were using this formula. This answer right here is when we were using this formula. And so that way you can see kind of both of them being used. All right, well, let's try some examples. Our quotient rule for exponents. So quotient rule for exponents. Here we have kind of a mess on our first example. And so just, again, I'm just double checking to make sure that every single one of my bases in the number 1 are all 3's, so that I can just work with the exponents. And that's the case. We have 3 for the bases all the way across. And so here that means that we can add our exponents in here. So I'm just going to write it as 3 to the 6th plus 2 minus 3. And then in the denominator, I'm looking at the fact that we have this 3 to the 0. 3 to the 0 is going to go to 1. And then we've got 3 to the 2 minus 4 minus 6. And so once we get that, you need to go ahead and do a little bit of math and figure out what that's going to be. So in our numerator, we have, for adding that up, 6, 7, 8, and then subtract 3. That's going to be 3 to the 5th. And then in the denominator, we've got 2 minus 4 minus another 6. So that's like 2 minus 10. And 2 minus 10 is going to give us 3 to the negative 8. And then again, I don't want to leave that negative 8 in the denominator. So to bring it up to the numerator, if we do that, so we can just either bring it up, and it's going to be 3 to the 5th times 3 to the 8th. And then in that case, we're going to have 3 to the 14th. Then you need to go ahead and evaluate that. And when you get 3 to the 14th, oh, sorry, that should be 13. Sorry about that. That should be 13. So 3 to the 13th. When we're evaluating that, again, put that in your calculator. And you're getting 1,594,323 for your answer. So again, make sure you can put that in your calculator on your own, and you're not just trusting me for the number there. You can always double check my work. All right, I'm going to jump over to number 3 because it's right there. And so looking at this one, we've got 30 x to the 5th, y to the 9th, times x to the 6th, because we're multiplying those exponents right there together. Then we've got negative x to the 15th, I'm going to go ahead and combine my y's. I see that I have y to the 4th and y to the negative 6th, so I'm going to combine those. So 4 plus the negative 6, or 4 minus 6, is going to give us y to the negative 2. And then we still kind of have a mess. So I want to go ahead and work with my numerator, just one more step. And the other thing I'm going to do is I'm going to bring this y up. I'm going to bring it up to the numerator so that I have it as a positive exponent. So I'm going to do those two steps in one. So I've got 30 times x, and I'm going to add these two together. So we've got x to the 11th, and then I've got y to the 9th times y squared. So this y squared at the end is from me bringing that y to the negative 2 up from the denominator to the numerator. And then what I'm left with is negative 8 times x to the 15th. All right, so let me scroll down just a tiny bit. All right, so here, next, I'm gonna go ahead and take care of these two pieces right here. So I'm gonna combine those, and then I'm looking at the fact that x to the 11th is less than x to the 15th. And so when I'm looking at those, the question I'm asking my brain is, where is the larger x? And it's in the denominator, it's x to the 15th. So that means that x to the 11th, I'm going to bring it down to the denominator, okay? So when I bring it down to the denominator, remember you change the sign on that exponent, so it's going to be to the negative 11th. I'm going to come up here. So now we've got 30 y to the 11th. Then we've got negative 8 x, and you should be taking to the 15th, minus 11, which is going to give you 4. My y tail is kind of here in the middle or in the way. That should be x to the 4th. And then at this point, we're done kind of simplifying our x's and y's, but is there anything we can take out of 30 and 8? And I'm hoping you're saying yes, we can at least take out a 2. So let's start with that. I see that they're both even. I can take out a 2. So then I'm going to get 15 y to the 11th all over negative 4 x to the 4th. And I'd say, can I simplify that anymore? No. So there's nothing more for you to take out of the 15 and the 4, so that's going to be it. So you have 15 y to the 11th all over negative 4 x to the 4th. All right, and that ends up being your answer for that one. So we've got 2 more here. And what I would like for you to do, I want you guys to try these 2 on your own and see what you get. I'm going to give you the answers, and I want you to see if you're able to get there. So this one should be 6x to the 6th. And this one over here should be negative 64 all over a to the 3rd. Or you can write it as negative 64 a to the negative 3rd. So either of those you can have for your answer there. So if you have questions on those, be sure to send those to me in office hours, or you can ask me about them in class the next day. All right, thanks for tuning in.